Hi, I'm Kyle Bradbury. In this video, I'll be talking about the Git version control tool, how it works, and how you can incorporate it into your workflow. So we've all probably been there. You've opened up a folder, whether it's something you're working on or somebody that is on a team that you're working with that is working on, and you see a file structure that looks a little bit like the one here. Lots of different versions, clearly files that have been saved, V1, V2, V3. Then you get to, somebody puts a final at the end, and there's not quite the final version, so you have to tweak it and get final 2, final 3, then you get final 5. Anyway, this is not obviously an ideal way to store versions of files over time, because it's very hard to go back through structure. It's very hard to do this in a collaborative environment where you might need to go back to a specific change when that was made, and version control helps us with that. So version control and Git as a tool for version control manages changes to code over time, and it really enables this easier collaborative development but through the tools that are part of the Git environment. And it provides a complete history of every change made to every file. And there are two kind of important pieces to this. There's Git itself, which is the most used version control tool. This is the actual tool itself. What does this do? It's a distributed version control system, works across most platforms, and can even handle files that have had their names changed but are pretty much the same. And it creates and maintains repositories for all of this data. Now that shouldn't be confused with GitHub and things like GitLab and other online repositories, which are web-based hosting services for hosting, a repository on the web to make collaboration over longer distances much easier. Now you don't need to put your Git repository up on something like GitHub, but it can be a lot easier for collaboration if you do. And GitHub offers private repositories and not just the free public ones, which are kind of the default option if you go and make a repository or repo, as it's otherwise known, on GitHub. So how does this actually work, though? We're going to talk about Git here, and when you start to think about Git, we have to think of what it means to have version control in the space. So you can imagine we start out with the first version of a set of files. Consider this a project. We'll call it version 0. And we might have files A, B, and C. And as we start to go through this and make some changes, we'll have some changes that are made, and maybe we edit files A and C. So A and C now have new changes, and so what Git does is it stores those changes made from file A and kind of stores that in its database, and the changes made to file C, but it leaves just kind of a pointer to file B saying, nope, that's unchanged, we're still good to go there. And as you continue to edit things, maybe you just want to edit file C, I get new versions, and each time I make a new version, I call it a commit. I commit this to the repository, and I effectively create a new version of that. So I might change just file C in this case, and then maybe the next edit that I make, I change file A and B, or just B and C. And over time, I build up a history, and Git has stored all of the changes in that history as I've gone along. So if we look at what's actually, how we actually go about doing this, there are a few different locations here. We're going to divide this up into those locally, meaning on our own machine, and those that are kind of remote, that you might push to. It could be a server that you have in your amongst your team. It could be something like GitHub, but that's going to be the remote where it's stored and synced among a number of individuals. And so we start with our working directory, and this is a directory on your local file system, C drive, whatever the drive is. If you're on Windows, if it's on Mac, it might be your primary drive. And we're going to have a staging area, and this is going to be where you tell Git what you want to commit to the repository and what you don't want to. And we'll get into what that looks like in a minute. And so basically from your working directory, we have all of our files. Then the staging area tells us what we're going to get ready to put in our repository and what we're not going to. And then we have the actual local repository itself. Whatever's been staged there, we can set it up to actually commit to that local repository, which will have the version history there. And then we can have a remote repository such as GitHub that we can send those any changes from a local repository to, or sync it with that remote repository if others are working on it and we want to get the changes from there. So how does it actually work? Well, we can start from our working directory by adding any changes to the repository using the git add command. So this stages our change that we made to a file and says, okay, I made a change to this file. I want this to be added to the local repository. So let me put it in the staging area while I gather up all my other changes that I'm going to add. And then I'll be able to go ahead and put that into the local repository as part of one new version update, so to speak. So I might make a bunch of little changes. If I had a few different files that I was changing, I add them to my staging area and I get it ready to then be committed to the repository to create a new version. And then so to actually create that version, I use the git commit command, and that takes everything that I've gotten ready in the staging area. That was basically, I said, okay, all these files in my working directory that I've added to the staging area, we're ready to go, store them in the local repository. And then from there, if I say, okay, the changes that I've made in my local repository, I want to actually get up onto my remote repository on GitHub or something like that, I can then use git push. So each of these, add, commit, push pieces help me to, get files from, changes that I made in a version in my working directory to the local repository or to the remote repository. Of course, sometimes we might make some mistakes or change our plan along the way. And let's say we've added some files to the staging area that we said we wanted to get ready to make into a new version, but we decided, no, actually, I do not want to have those staged to be added to the repository. I can use git reset to kind of undo some of those changes. Now, of course, I may have also committed a change that I didn't actually want to commit to a new version. I can actually go back to previous versions of the project. Instead of being at version 7, I want to go back to version 6. I go ahead and do that with git revert. And so those are kind of my undo processes. Now, of course, I might be going along here, and I've been working in my local working directory, and some of my teammates have been working in the remote repository, made some important changes that I need to incorporate into my workflow before I end up deviating too much from the work they've done. Now we go ahead and do that with the git pull command. We update from the remote repository, we update our existing working directory and incorporate those changes into the history through another process that is called git merge. But the pull command will pull down the latest the latest stuff from the remote repository. So if you're working in a team environment, what you might want to do is before you start working on the project, run a git pull, get the latest changes, and then work from there so you're up to speed with what's the latest work that's been done there. Now, the other thing you can do is if you're just starting out a new repository, you can initialize it, or you can just say, okay, I actually want to start from the starting point of an existing repository. So you can use a git clone command to do sort of a one-time download of what's been put in a repository, basically copying it down, and then from then on, you'd be adding changes to it along the way. So let's look at what this looks like in a workflow. And here we have a number of things going on here. So if we start off here, you can have a number of what are known as branches in your in your Git repository, and on these branches are different levels of change. So, what we have here, these circles each show what is a commit that's been made to the repository. So if you're on this master branch, let's just assume we're on the main branch. If you kind of ignore everything else on the master branch, you just you make your changes, and those represent each of your major versions, right? So you can just do everything on your master branch, and if you're just one person doing an individual project, that might be just fine. But if you're working with a team, you might want to have a main project that is nice and bug-free and going along, and then while you're doing that, be developing some potential additions to this that you might want to incorporate later. So perhaps you're going along here and you just start to develop a new feature. So what you can do is you can start creating these branches, which are deviations from the main master branch, but which can allow you to add in new features and kind of work on those independently of other changes that might be made to the code base. So perhaps you're starting to develop things, and there's kind of a main development platform, and then main development branch, and then you add in a feature that's takes a few days or a few weeks, and then you kind of merge that back into that main development branch, and as you're doing that, you might say, okay, well, I need to then reconcile some changes we made in developing these features with the master branch, and so maybe you have sort of another branch which is your release branch, trying to get it ready to to merge your changes from your development branch with your master, and then you incorporate that into the new version. But sometimes some of your feature branches may not go anywhere. You might work on them a while and say, this is not something that I want to incorporate into this project, and so they may not go all the way through. But what this allows is a clean master branch with your main versions that are working along the way. You might have some hot fixes to say, okay, well, we're going to fix some bugs that we encountered in the code base along the way. But this allows a clean master branch and your development branches to help out through that. So how do we actually go ahead and get started implementing this? So step one, go ahead, download and install Git. This link will direct you to the right location for that. Then go ahead and create a new local repository in a local directory. So to do that, you can just start with a blank directory or an existing directory that you have on your computer that's not already a Git repository, and you run the git init command, and that will initialize that repository. Or you can start working on a project that somebody else had started, and so you can use git clone, and that copies whatever was in a remote repository into your local directory and initializes it as a Git repository. And so then you can develop it from there. Then once you've done that, you can create you've created your project, you can start committing to it your changes with your different versions as you go forward. So here you use your git add, git commit, all of these commands to add your changes in. And of course, then you can share your work and collaborate using the git push command, help making sure that whatever changes you might have made in your local repository are merged into the larger larger repository that you may be collaborating on with others, and this might be to GitHub or whatnot. So let's look through exactly what some of these commands end up doing. So one that we haven't talked about yet is git status. This is kind of, let me just check what's going on. Let me inspect the staging area. You probably want to run this pretty regularly to make sure you know exactly where things stand in your project. So when there aren't any changes, you'll see something like this. On branch master, so this tells you what branch you're working on. There's nothing to commit. Working tree clean. So there are no changes to be added to a repository. But now when there are changes, you see something different. So on branch master, changes to be committed. Here's a list of them. And so here, there's a new file. So maybe it's file a.txt. It's been added. It wasn't there previously. And there was a previous file that's now been changed. Some of the content of it has been changed, so it indicates it is modified. Now, you'll also see a list of untracked files. So these are files that have not been added into into the staging area using git add, but were found in your working directory. So it might be another file.txt and file B. You'd have to use git add to add these files into the staging area. So these are the changes that are staged to be committed, and these are untracked files that will not be added to your repository. Again, you can always, if you see things in here, you can use git reset to take them out of the staged files, or git add to put them in. So another command that's important that we probably want to talk about here is git log. So what this lets you see is a history of all of your commits, of all of the versions that you have here. Now, obviously, this looks like a lot of stuff that's been going on here, right? So a lot of content. You have this commit paste, the merge, author, date. So given all of this, one thing that you want to look out for, to kind of unravel what this means, you have your commit and then this number. This is a unique identifier, sometimes called a commit hash. This is a unique ID that represents your individual commit, and these are usually quite distinct. So when you start referring to these, you can usually refer to them by the first few numbers of the unique identifier, and Git will be smart enough to know which one you're pointing to. It tells you the author who made this, and the date in which it was, this commit was added, and then it also shows you what the message was associated with this particular commit. So this one was the initial commit. In this one, there was a changed file name, merge the development branch into master. So it gives you some information of what was done in each of these versions. And so you can then say, well, what are some of the? You might ask yourself, what are some of the differences between these different versions? How do I see those differences? Well, there's another command for that called git diff. Allows you to inspect the differences. So let's say we have a file called myfile.txt, and say it's on branch master, and here's the contents of the file, and we'll have the line numbers next to it to kind of for clarity when we look at this. Let's say we have on another branch, we'll call it on branch dev, this file has its name has been changed to myfilechanged.txt, and you can see some of the text of the file is different in and of itself. So there are some changes made here. So you can run a command, git diff master dev. So this is going to look at the differences between the master branch and the development branch. You could also look at differences between different commits. So, those IDs that I was showing earlier, you could look at differences between that. And this is going to show you the differences. So what does this spit out? Well, this spits out this, what initially looks like a fairly complex set of information, but if we break it down, it gives you actually a lot of information of what's going on here. So first of all, it shows you here we're comparing files. It's labeled myfile.txt as file A and myfilechange.txt as file B, and so it'll use those for this comparison going forward. It also is saying that it sees that the similarity index between these two files, myfiletext and myfilechanged, is about 56%. And since it's high enough, Git knew that these were the same file, but just renamed. So it said rename from myfile.txt to myfilechanged.txt. So it actually recognized that along the way. This gives you the commit hash and file mode, and so the hash itself, and then the file mode is the What are the write privileges, read-write privileges? Can you write to it? Can you just read from it, etc.? And then it designates file markers to indicate what the differences are. So in this first example here, myfile.txt, it's showing that these dashes will be used to indicate myfile.txt, file A, and the plus signs will be used to indicate myfilechange.txt. And so then we have here the file chunk header. So what this is saying is, between these double @ signs, it'll tell you the file range of file A and file B that will be included and compared below. So where each of the ranges of here are given by first the starting line and then the number of lines that's included. So if we look at file A, this is saying it starts at line 5 and goes for 7 lines. So starts at line 5, which is and then goes for 7 lines, which is through 11 here. So the text I did not write, space, no more comments. And if you look here, the text that was included at the top here, and then did not write, no more comments. It's all there, that's the chunk. And then it shows the differences between these. Here, the dashed ones, did not and write, were only found in myfile.txt, while never wrote was in myfilechange.txt. So it's showing you the differences between the two. And then here, it's showing, no more comments. Again, that's only in this myfile.txt. And no comments but my own was in myfilechange.txt. So this is giving you what the differences are. So you can use this to understand what the changes were. And identical text in both A and B, differences only in file A, only in file B. This is a whirlwind trip through some of the main commands in Git. I'm going to be following this up with another video, specifically going through a demo of how to use Git command line tools. I hope this was helpful for getting a little bit of a grounding around Git, what version control is, how Git works, and some of the basic commands. And thanks for watching.